All right. So today we're going to talk about delegation and protocols. And these are two different things, but they work together really well. So let's get started. So we're going to start with a protocol. What is a protocol? Protocol is a contract or a promise that your class makes. So you're setting up your own custom class. And if you are going to include a protocol, then that means you promise that you will include specific properties and or methods. Okay? What does that mean? That means for an outside object or function that's accessing an instance of your class, they're guaranteed that certain properties and or methods will be available. For example, we have two classes here, a fruit class and a vegetable class. Okay? And an instance of fruit is an apple or a holly berry. An instance of a vegetable is a carrot. Okay? Now, holly berries we might not eat on account of the poison, but an apple and a carrot we would eat. So we may want to provide specific set of properties and or methods that let the outside world know about the fact that these are edible. So we're going to include protocols on these two guys. Okay? And this protocol that apple and carrot are implementing is the edible protocol. Therefore, any outside person, for example, looking in, knows that it can query apple or carrot about how many calories it has or about what the flavor is, okay? Because they conform to the edible protocol. So how does this work in code? If I were an outside class, let's say my class is a person class, and the person is interested in whether an apple or a carrot is tasty or how many calories it might have. Let's say those are the two methods that are within the edible protocol. Then in my function, I know that I can create an instance of an apple. Right here, we do an alloc init, right? And my apple is going to hold that instance. I know that I can send a message to my apple. Message is called get calories. Well, the selector of the message is called get calories. And I know that that will return an int. Why do I know that? Well, because apple conforms to the edible protocol. But I don't have to make it an apple class, right? There may be an instance where I know that I'm going to get some piece of edible food, but I don't know what piece of food it's going to be. In that case, I can make a pointer to an instance, and beforehand I don't know what that class is, but I know that class will conform to this protocol. And I can declare that pointer some food. I don't know what that food is. Just like this, I can indicate, well, this ID is kind of like void. Okay, so I'm saying ID conforming to edible protocol. There's going to be some food, and I can alloc init either a carrot or an apple. Either one of these can be held by some food. Look at the way some food is declared. They're exactly the same. In either case, some food we're guaranteed to have a property or a method called get calories. So that's nice to know. Okay, let's imagine a second example about protocols. Okay, in this case we have a student and a professor. Now, some way, somehow, the professor needs to get the grades to the student. Okay, because the student is turning in an app. So, how do we do that in our class? you as a student, you conform to the Blackboard protocol. Okay, so I know I don't need to know anything about the student whatsoever with respect to giving out grades, other than the fact that you can receive your grades on Blackboard. I know that if I put it on Blackboard, you'll get a notification, and that's how you find out about your grade. So I'm not going to post any grades until you first turn in an app. Okay? And then you've got better things to do other than wait outside my office until the grades are done, right? And besides, who knows how long I'll take? Maybe I'll take 1 day or 2 days or 3 days. So you turn in your app, you go about doing your business. I acknowledge receipt of the app, and then you're free to do other work while I grade the app. Then once I'm done grading the app, I notify the student via the Blackboard protocol once the grade is complete. And this is kind of highlighting the second concept that we're learning about today, which is called delegation. So here we have a block diagram of what we just talked about. A student wants to be notified when the grade is updated. So what the student is going to do, is student is going to conform to the Blackboard protocol. So that means the student promises that she will receive her grades through Blackboard. Okay? So the student notifies the professor, and this is called, sometimes we'll say registering, or in this case we're going to say the student is going to add herself as a delegate. Okay, so now the professor knows that this student wants to be notified via Blackboard once something is ready. In this case, it's going to be the grade. So student adds self as a delegate, and then, you know, the professor goes about doing a job. In this case, the job is finish grading the app. Okay, but this could really be anything. We could think of this as a network call, or a large job, or even a separate thread, or a user input. Right? This could be any type of job. And when, in this case, the professor is done grading the app, then the professor knows that it can call whatever it is, update grade, or whatever the name of the function is that's defined in the Blackboard protocol. Okay, professor knows that that method can be called on student, and student will receive the message via this protocol. And this is what's called a delegation. And it extends the concept of a protocol by allowing messaging between unrelated classes. These classes don't need to know about each other. As long as student is added as a delegate, then student will receive messages, a notification, whenever something is ready from the professor. Let's think about an audio example of this. So we've already looked at the EQ coefficients project. And this is one of the requirements for your project, isn't it? So let's say we've got some sort of filter calc, I called it, filter calculation protocol. All right, and there's one required method inside filter calc, and it's did update coefs. So if we go over to our EQ view controller, we want to separate out all of the model stuff out of the view controller. And the view controller is just going to handle interactions with the GUI. So step one, but the model underneath may be updating the coefficients from time to time. So what the EQ view controller is going to do is going to conform to the filter calc protocol. It's going to implement did update coefs, which can be called by LPF calculator. EQ view controller will then add itself as a delegate with the LPF calculator, or the coefficients calculator, whatever you're calling that. So then Um, the coefficients may be changed by, of course, by the user, which would come from the view controller, right? Maybe the user update the center frequency, for example. Or totally outside the user's purview, maybe the DAW is changing something. Maybe the DAW is changing the sample rate, right? That's not something that the view controller would even know about until the LPF calculator updates the coefficients. So in either case, either the user changes a setting or the DAW changes a setting, LPF calculator knows that it can call did update coefs on EQ view controller. Now once the EQ view controller gets the updated coefficients, it can update its labels. So the LPF calculator knows the method will exist, even though there's no did update coefs defined in the interface of EQ view controller. Why does it know that? Well, EQ view controller is conforming to the filter calc protocol. I hope this is making sense. And there can be more than one delegate. So let's say this wasn't just displaying. So right now your EQ view controller is just displaying the coefficients. But what if we were pumping audio through and we also wanted to have some sort of DSP applied? We want to actually apply those coefficients to some real-time audio. Well, guess what? Our DSP might want to also conform to the filter calc protocol so that the moment that the user or the DAW makes any sort of change, well, now update coefs is going to be called on both the EQ view controller so it can update its labels, as well as the DSP, right? So that it can update its filter. Pretty cool. All right, so let's look at another delegate example. In this case, it's not going to be audio related, but that's okay. So imagine we have a customer driving a car, pulling up to a gas station, and is met by the attendant. So the car has a tank level. That's like a property, right? It's just a number, 0 to 100. The customer has to get the gas from the attendant. So the attendant is doing some work. What work is the attendant doing? He's filling the tank, checking the tank to see if it's full, add more gas. Check the tank to see if it's full, add more gas. Check the tank to see if it's full. Okay, tank's full. Then the attendant notifies the customer that the customer can drive the car off. So we might even say it's standard protocol for the attendant to notify the customer that she's done filling up. All right. So filling the tank should not prevent the customer from doing other things. For example, reading a book or studying for iOS. And additionally, each customer may respond differently, right? So the attendant doesn't have to know anything about the customer, what the customer is doing, how the customer wants to respond. All that the attendant needs to know is that the customer conforms to the standard protocol. The customer has a way of being notified that the tank is done being filled up. So we can imagine some sort of hierarchy like this, or a class relationship, I should say, like this. The customer owns a car, right? This is going to be a strong reference, won't it? Between the customer and the car. This will be a strong reference. And the car may have a weak reference back to the customer. All right. The car owns the tank level, but the customer can always know what that is. The customer also has this method to tell the attendant, hey, I want you to fill my tank and notify me when I'm done. So what the customer is going to do is add himself or herself as a delegate. Now the attendant can go about his job of filling up the tank, and the customer can go about his or her job of whatever they want, like we said, reading a book or surfing the internet, whatever. And when the attendant is done with the job, the attendant knows that there's going to be some way of notifying the customer that the tank is now full, right? And that's because customer is conforming to this protocol. And we're going to look at some code examples of this right now. So if you flip over to the next video, we'll look at that.